Hello, distinguished viewers all over the world. Welcome to Simplified Maths Class. And I am your host, Mr. Mike Omini. But please, if you have not subscribed to our channel, kindly do that by clicking on the red subscribe and on the bell notification. And God bless you as you do that. All right, so we, without waste of time, will be taking angles of elevation. And please, if you have not watched our slide, the use of SOHCAHTOA in solving right angle triangles, kindly do that, and the use of Pythagoras theorem. Those two concepts will help you a lot when you are solving problems that involves angle of elevation and depression as well. All right, but today we'll be taking angles of elevation. Next time we'll take angles of depression. All right, so a question is given on the board. They say the boy observes that the angle of elevation of the top of a tower 50 meters away. All right, so this is a tower. That's a tower. All right, and now they say the boy here, this is where the boy is, observes that the angle of elevation of the top of that tower 50 meters away. All right, so if this is the tower and this is the ground level, from here to where the boy is 50 meters away. All right, it's 30 degrees. So the angle of elevation there is 30 degrees. So you should find the height of the tower to the nearest meter. We want to get the height of the tower to the nearest meter. All right, so we have to bring the concept of SOHCAHTOA. All right, and SOHCAHTOA, the sine angle of theta is opposite over hypotenuse, and then the cos angle of theta is adjacent over hypotenuse, and the tan angle of theta is opposite over adjacent. So from what we've been given, we have to find out which of the three trig functional ratios are we supposed to use. It the SO, the CA, or the TOA? All right, so let's see. Understand that in a right angle triangle, this longest side is the hypotenuse. Please don't forget that. We've taught this extensively in the last two topics we've talked about. And then, if this is the hypotenuse, the longest side, the side facing the given angle is called the opposite. So this side is the opposite. Here is the opposite. And of course, the other side is called the adjacent. All right, so how do we know the particular trig functional identity to use? Either the SO, the CA, or the TOA. Understand that with the angle theta given, all right, we are to find the opposite. All right, we are to find the opposite, and the adjacent is given as 50 meters. We are to find the opposite, and the adjacent is given. So the opposite and the adjacent is important. And where do we have opposite and adjacent in the trig functional identity? It's only in TOA. So we only have that here in TOA, opposite and adjacent. Whereas in sine, we don't have opposite and adjacent. In cos, we don't have opposite and adjacent, no. So it's only in tan we have opposite and adjacent. So it means we are going to use TOA. And TOA means the tan angle of theta is equals to opposite all over adjacent. That's the meaning of TOA. All right, so the angle theta has been given as 30 degrees. So the tan angle of theta is opposite. The opposite side is the height of the tower we are looking for. All over the adjacent. The adjacent is 50 meters. So we'll make this over 1 and cross multiply. H times 1 will give us H is equals to 50 times this will give us 50, the tan angle of 30 degrees. All right, so this will be 50 times, the tan angle of 30 degrees should be 0.5771. Let's see, the tan angle of 30 degrees, tan 30 degrees will be 0.5773. All right, so 0.5774. So we'll multiply that by 50. We'll multiply that by 50. So we'll have 28.8687 meters. So the height is 28.87 meters. And we'll be asked to find this height to the nearest meter. Therefore, the height of the tower to the nearest meter will be 28.87. 8 here will affect here to become 29. So that will be 29 meters to the nearest meter. And of course, which is the B part. All right, so that's a JAMB problem that was given some time ago. All right, so we have that as 29 meters. So that's the height. Okay, but sometimes in a particular question, they might give you the height of the person who is observing the angle of elevation. And then if they ask you to find the height of that building or the height of the tower, you incorporate the height plus the height of the man to give you the height of the building. So let's take a problem like that. It happens both in angles of elevation and angles of depression as well. All right, so let's rephrase this question. Let's say, for instance, a man, let's say the man is 2.8 meters tall. Observes that the angle of elevation of the top of a building, let's say the top of a building, maybe the top of a building 47 meters away is 30 degrees. Let's change the angle. Maybe this time around the angle is 60 degrees. Find the height of that building. So if you find the height of the building to the nearest meter, or maybe this time around to 3 significant figures. All right, to three significant figures. All right, so this is another question. This time around, the height of the man is incorporated into the question. It is key to understand that when you are looking for the height of that building, you must incorporate the height of the man. All right, so let's extract out this question the way it is. So let's see what we can do with this. So we have this. This is a building. All right. Now, this is the height of the man this time, so it's incorporated. Please take note of this. Now, this is the height of the man, 2.8 meters. So let's say the man is so tall, he's 2.8 meters. So this is the man, M. All right, that's his eye level, and this is his foot. This is where the man's foot is. All right, so this is the ground level, and that's the building. So this is the building and the ground of the building. And let's say this point can be, let's say, K, point K. Now understand that if this is 2.8 meters, here also will be 2.8 meters. Take note of that. So they've given us this angle here, the angle to be 60 degrees. Here is 60 degrees. And they've said from the building to where the man is 47 meters away. All right, so let's take note that here is 47 meters. And of course, if from here to here is 47 meters, also note that here too, from here to here, will also be 47 meters. Please don't forget that. It's the same thing. They are the two opposite sides of a rectangle. They are equal. The two opposite sides of a rectangle, they are equal. And now they want us to find the height of this building, meaning from here to here. So from here to here is the height of the building. All right. So for us to get the height of the building, we are going to make here, let's call it a small x. So that when we get small x, we'll add the small x to 2.8 meters to give us the height of that building. So that's all we need to do. All right. So before we proceed, we have to bring out the second triangle. All right. So this is our second triangle. All right. So we are bringing out B. Here, B, K, and M. Here was given as 60 degrees. Okay, so we've known here to be 47 meters. I want to calculate small x. So we only extracted the triangle out, leaving the rectangle. So we extracted the triangle out. X here so that we can find the value of x and then add 2.8 to give us the height of the building. That's all we need to do. And as usual, again, we now look at all right, the use of SOHCAHTOA in solving this problem. And if you look at it, this is the opposite side and this is adjacent. So we want to find the opposite and the adjacent is given. So opposite adjacent is still tan. So we are using the tan. All right, so if you are using the tan, understand that the tan angle of theta is opposite all over adjacent. The theta now is 60 degrees. So the tan angle of 60 degrees will be equals to opposite. Opposite is x. All over, the adjacent is 47. So we have 47 meters. So make this over 1. So we are looking for x. X times 1 will give us x will be equals to 47 times this will give us 47 times 60 degrees. Please take note of that. So we are going to have x to be 47. The tan angle of 60, 1.7321. Tan angle, tan angle of 60 degrees 1.7321. So that will be 1.7321. So we'll multiply that by 47 times 47. So that will give us 81.41. 81.41 meters. Therefore, the height of the building, all right, so the height of our building, which is our H, will be equals to x plus 2.8. So that will be x plus 2.8 meters. X just gave us 81.41. It's 1.41, so we add to 2.8. That will give us the height. So 81.41 plus 2.8 will simply give us 84.21. 84.21 meters. And they say we should approximate to three significant figures: the first, the second, and the third. So that will be 84.2 meters to three significant figure, which is the height of the building. Please understand this, all right? The only difference between this example and the previous one is the fact that the height of the man was given. And so if you're looking for the height of the building, you must incorporate the height of the man to the height of the building for accuracy. And that's what we did. So after getting x, which is 84.41, we must add the height of the man to give us the entire height of the building. All right, so please take note of that. All right, until we'll meet next in the part 2 of this, which is angles of depression. But before then, there is this unique questions they give in angles of elevation and as well as angles of depression that has to do with two-dimensional problem. That means two angles will be given. Say two people on the ground level observe the height of a tower with two different angles of elevation, let's say 30 and 45 degrees. And you've been asked to find the height of the tower or the distance between the two men. Such a problem is this angles of elevation and depression two-dimensional problem. I think that's the next one I'm supposed to show you in our next slide. It's very important. You can't write exams without, skipping that. So don't forget to attend the next slide, which is angles of elevation part 2, in order to solve a two-dimensional problem where two angles of elevation are given. But before you attend that class, if you have not subscribed to our channel Simplified Math Class, kindly do that by clicking on the red subscribe. If you have any question with this one-dimensional problem when one angle is given, kindly ask that question in our comment section and we'll respond back to your question. And of course, please make sure that you don't miss any of our slides whatsoever to become the professional mathematician that you ought to be. And the only way by doing that is to click on the bell notification after clicking on the red subscribe, so that you won't miss out in any of our exciting topics in mathematics. God bless you again, and I am your host, Mr. Mike Omini. See you in the next slide. Cheers.